This is our last major example of simple harmonic motion. This is, we're in 4.8, day 2, and we're doing applications of trigonometry. And so we have a Ferris wheel this time. We're talking about simple harmonic motion, which again is, things like just repeated behaviors of certain objects, a spring oscillating back and forth, a pendulum swinging back and forth. In this case, it's going to be a Ferris wheel. So we have a Ferris wheel because we start at this position and eventually you will get all the way back around it. That's one complete revolution. That's one complete cycle or period of this harmonic motion here. So we're going to either have a sine or a cosine graph, but let's take a look at some of the stuff that we've got going on here and answer our series of questions. Consider a Ferris wheel that's 16-meter diameter. Well, if that's a 16-meter diameter, that means that the radius here is 8 meters. Okay. It turns at 3 revolutions per minute, so 3 complete revolutions around the circle in 1 minute and 60 seconds, with its lowest point 1 meter above the ground. All right, so that is right here, 1 meter. So you're going to get on 1 meter before the ground. It's a good thing too, because if you didn't get above the ground here, it'd be scraping the ground. We don't want to scrape the ground with the Ferris wheel. Then it says the height above the ground of a person riding the ride is a sinusoidal function of time t, where t equals 0 represents the lowest point of the wheel. So this t equals 0 is right there. Now it says h is our height. We're going to use that as maybe our variable in this case for y. It says how long does it take to complete one full cycle or period in this case. Now the key here is that we have 3 revolutions per minute. So that means 3 times all the way around in 1 minute or 60 seconds. So that means that we do 1 complete revolution or 1 full cycle in a third of that, which is going to be 20 seconds. So now if we've got 20 seconds as the period and we want to find the value of omega, remember we had that formula from a previous example where it was 2 pi divided by omega is equal to the period. Well, the period in this case is 20 seconds, which is a good thing because they're asking us to provide this in seconds. We're going to find out what omega is. You might want to just quickly pause the video, see if you can get the same thing as me. But omega is going to be pi over 10 if you solve that. Next, what is the amplitude? Well, the amplitude is how far above or below the center that this thing goes. And the center of the Ferris wheel here we might want to just represent with a dotted line. That pretty much just represents the x-axis in this case. So that x-axis is the center. How far above or below do we go? Well, that's the radius of the wheel, so that's our 8 meters. And so we say the amplitude here is 8. Next, is it sine or cosine? Now remember the difference between the two. Sine is where we start in the middle, usually 0, 0. Cosine is where we start above or below the middle. So in this case, we're starting down here. That's going to make this a cosine graph. And so we have pretty much all the information we need now to make an equation for this, except for one thing. Notice that the center here is up high. It's not on the ground. If we were to make the center at 0, that would mean like the rest of the Ferris wheel would go underneath the ground, and that wouldn't be a very exciting Ferris wheel. So how far above is this? Well, the wheel is 8. There's this extra 1 here, and so to get from here down to the ground, that is 9 meters. And so we need to take that into account when we're making our equation. All right, so I guess we're going to replace y with h in this case. That's the height. And we have 8 cosine. But keep in mind that it's down here. It's starting below, so we should do negative 8 cosine as the start of this equation. So negative 8 cosine, and then on the inside is our coefficient omega. So that's pi over 10. And then their variable of t, that's the x value in this case, x variable in this case. And then the thing that I was pointing out here with this 9, we're 9 above the ground, we're 9 above 0, so then we'll have to have a plus 9 for this formula. So there is our equation for this harmonic motion. Now the last question is to use the equation and figure out where we're going to be at certain times in the process. We'll come back to the t equals 4, but I just wanted to let you know about t equals 10 first, because we actually don't have to plug this in. We could just think about the fact that 20 seconds is all the way around. So if we're talking about 10 seconds, that's halfway around. This is where we'll be at with t equals 10, which is the very top of that Ferris wheel. Well, if we add these two together, the 8 and the 9, that would make our height equal to 17 meters in this case. So at 10 seconds, we'll be 17 meters above the ground. Now, with the t equals 4, we actually, for that one, have to plug it into the formula, and it's not going to be a big deal as long as you do it correctly on your calculator. We just need to plug in, so we've got -8 cosine pi over 10 times 4 seconds, and then plus 9. As long as we have the right mode on our calculator, that's all we'll really need to do. Oops, sorry, I didn't show you that. That's all we'll need to do is just plug it in. So make sure, in this case, we got to be in radian mode, so please make sure that's selected. And so we'll do -8 cosine of pi divided by 10 is our coefficient times 4, close off the parentheses, and then plus 9 on the end. So we've got about 6.53 as our height there. Height is about 6.53 for at t equals 4. Now you always want to go back and see, does that seem reasonable? So at t equals 4, if this is 10, if it gets 10 seconds to the top, then it must get halfway by 5 seconds, and so 4 seconds is going to be a little less than 9 meters. Seems like that's a reasonable amount to get there. So that checks out, and that is what we're looking at for the harmonic motion based on a Ferris wheel. If you have any questions, please let me know as usual.